welcome to this video. We're going to talk about the perfect squares and the perfect cubes. What are they? Well, if you have a number and you raise it to a power of 2, then that result will be a perfect square. Or, phrased differently, if you take a number and multiply it by itself, then the answer to that multiplication problem, that's going to be a perfect square. Likewise, if you take either that same number or a different number, and you multiply not just by itself, but 3 copies of itself together, then that result will be a perfect cube. So we have a list of 1 squared to 15 squared, and also 1 cubed to 12 cubed. This is the list of perfect squares that show up relatively often in Algebra 1. And so let's fill in this list. 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, but it's not because it's this number times that number. It's because it's this many of those multiplied together. 2 squared, I feel like, throws the most people off because they expect that they should be multiplying these two numbers together, and then the next perfect square that I see a lot of people try to say is 6, because 3 times 2, after all, the previous one was 2 times 2. But that's incorrect, because again, the definition says take this many of those and multiply them together. So we should have 3 times 3. Let's go ahead and finish filling in this list. So here are the perfect squares from 1 to 15 squared. Likewise, we can calculate the perfect cubes easy enough. All we have to do is take this many of that number and multiply them together, which for ones, those are going to be easy because no matter how many ones you multiply together, your end result will be 1. But this one is 1 times 1 times 1, which is 1. Again, be careful of that common mistake saying 2 times 3 is 6, because 2 times 3 is 6, but that's not what this statement says. It says take 3 2's and multiply them together. 2 times 2 times 2 is 8, because 2 times 2 is 4, and 4 times 2 is 8. So that's our answer here. I'll go ahead and finish up this list as well. That is the list of all the perfect squares and perfect cubes that you could probably get away with knowing and be absolutely fine in Algebra 1. There are more, of course. 16 squared is 256, and so on and so forth. If you take any number, not just these ones, and you multiply them together, either twice or 3 times or whatever, then that's going to be a perfect square or a perfect cube. So that's it for the list. Let's see what you can do with these. I have this number 108, and I'm going to look at it in 2 different ways. First, I'm going to look at it with the word square in my mind. I'm going to have that phrase perfect square in my mind. 108 is not a perfect square. If you go back and check, it is not on the list. But what I can do is I can try to find a perfect square, and it's what I like to call hiding in this number. So 108 is divisible by a lot of things. It's divisible by 2. Which means that 2 times 54 is 108. But 2 is not on the list of perfect squares, nor is 54. So while this is true, and there's nothing wrong with saying 2 times 54 is 108, if I have the phrase perfect square in my mind, then that's not a combination of numbers that I want to use, because I can choose which numbers that I want to use, and I'm going to choose not to use that one. Instead, I'm going to go with 3. Let's see why. When I say that it's divisible by 3, well, that means it's 3 times 36, because 108 divided by 3 is 36. And the reason that I would want to use this combination is because 36 is a perfect square. And it might be true that 3 is not. As long as part of it is a perfect square, I've accomplished my mission, my goal. Now, why would I want to break down a number like this? Well, because in a future lesson, we're going to be learning about how to simplify square roots. And if the problem doesn't give you a perfect square, then you need to use this strategy where you break numbers apart. We're not there yet, though, so we'll just continue on this path and see where else it can lead us. So if I have 3 times 36, well, I wanted that because 6 squared was 36. And one of the fundamental things that you learn in algebra and before is that if you know something is equal to another thing, then you can replace it with that thing. I know 36 is the same as 6 squared. They are equivalent, which means that I can rewrite this like so. So 108 is the same as 3 times 36, and 3 times 36 is the same as 3 times 6 squared, because 6 squared is 36. So that's one little trick that you can do, and again, this comes in handy once we're learning how to simplify square roots. Likewise, I can use that same idea and do it with a different phrase in mind, not perfect squares, but perfect cubes. 108 is 2 times 54, and it is 3 times 36, but you know what else it is? It's 4 times 27. And why is this a better option if I have perfect cubes on the mind rather than perfect squares? Well, because 36 is a perfect square, but 27 is a perfect cube. So when we get there and learning about how to simplify square roots, we're also going to be learning about how to simplify cube roots that are not perfect cubes. But again, that's for later. For now, we'll worry just about breaking the number down into the appropriate type. So 4 times 27 is what I want because 27 is a perfect cube. Even though 4 is not, that's fine as long as part of the number has been broken down into one of these perfect cubes. Okay, the reason that I chose 27 is because 3 cubed is 27, meaning that it is a perfect cube. And just like I did with the 6's, I can replace something with whatever I know it is. 27 is 3 cubed, and so I can rewrite this as 4 times 3 cubed. And I think that'll do it for this lesson. We've learned about the perfect squares, we've learned about the perfect cubes, and we've learned about how to break down a number using multiplication and division into a statement using these perfect squares or perfect cubes, how to rewrite a number into an exponential type form. So that'll do it for today. Thank you for watching. I hope it was helpful. I'll see you again next time. Bye-bye.